I'm Dr. Pranjal from Electronics and ICT Academy, IIT Guwahati, India. So I will be presenting the article Electric Vehicle Battery Supply Chain and Critical Materials Brief Survey. So basically, this is a summary of the existing work only. So we are focusing on the critical materials and the supply chain dynamics and the key players in the market. So start with if we go to the recent statistics, then EV sale is gradually increasing over last 2-3 years. Europe has increased its EV sales up to 2.3 million by 2021, and USA is contributing more than 10%. So China is in the leading pace. So as per the estimation, so electric vehicle cost will be almost equivalent to the IC engine vehicle, and so that the battery prices will also fall up to 73 euro per kilowatt hour by 2030. So it says that the battery demand will be dramatically increasing. So if we see the demand plot, we can see that the global demand by 2020 it is 300 gigawatt hour per year. That is the energy. And country-wise, if you see, the China is the growth in the China is accelerating. It is up to 180 gigawatt hour per year. Then following Europe and USA also. So then basically critical materials for the lithium-ion battery, or mostly the electric vehicle-based batteries are lithium, cobalt, and nickels. So these are the primary materials. So despite abundances, these materials, the mining of these materials need to improve the capacity. So so if we see the use of lithium in the electric vehicle purpose and the other purpose, in 2022 it is almost equivalent, and the cobalt is also increasing in electric vehicle as well as the nickel. So cathode materials, there are basically 3 cathode chemistries available. One is that lithium, nickel, manganese, cobalt oxide. This is nickel-based chemistry. And another nickel-based chemistry is lithium, nickel, cobalt, aluminum oxide, which is termed as NCA. And other type is lithium iron phosphate, LPF. So nickel-based cathodes are dominating in the market because of their higher energy densities. However, the LPF batteries, they are widely popular because of their long life cycles and stable chemistry and cost-effective compared to the nickel-based chemistries. Then anode material, graphite is the significant anode materials, and China has the 80% global supply of the graphite. So graphite is mostly dominated by localized in a particular country. So if we see the plot here, I have plotted anode, cathode, and nickel-based cathode and LPF-based cathode. So you can see that nickel-based cathode demand is accelerating compared to the other LPF, and anode is always necessary. So obviously anode will also increase. Then this is the basic supply chain of the electric vehicle batteries. So mining, raw material, processing, cell components, battery pack development, use and recycling. So lithium mining. So lithium, nickel, cobalt, graphite, and manganese. These are the essential materials. And lithium is basically available from brine and hard rock deposits. So brines are mostly concentrated in Bolivia, Argentina, and Chile. However, Australia is the major production of hard rock lithiums. Similarly, the nickel mining is also associated in two deposition process. So sulfide and laterite. So Russia, Canada, and Australia have significant sulfide deposits for high-grade nickel, which percentage of purity is 99.9%, and one is the low-grade nickel is also available from the laterite. So laterite is available in Philippines, Indonesia, this type of country. So cobalt and graphite. These are also, graphite is the anode material. Graphite, I have already said that the China is dominating in 80% of the graphite market, and cobalt is a byproduct of nickel and copper mining. So Congo, Switzerland, they are dominating the market by 70%. So manganese, comparatively, it is less expensive to low cost available metal. So yeah, its dominant manganese are manufactured by South Africa, Australia, Gabon, etc. So the next processing step is that raw material processing. Processing is very important for electric vehicle battery, because battery grade metal need more purification. So refining processes, it is expensive because it involves chemical treatment and heat treatment. So it is quite expensive. So the nickel processing technology also involve expensive mechanisms. So the 5 companies contribute 75% of the global production of any electric vehicle battery materials. China is leading manganese supplier, accounting for about 90% of the global production capacity. Then cell component manufacturing. So basically there are 4 parts of a cell, that is cathode, anode, electrolyte and separator. So I have already discussed about the cathode and anode, and electrolytes are basically salt and solvents that needs mixing and synthesis to produce. And separators are basically microporous membranes. It also has a ceramic layer. So separator production is a centralized business, accounts for half of the world's capacities. So then battery pack production. Battery pack production involves cell fabrications and electrode manufacturing. So the process requires a high control clean room. That's why it is an expensive business. So it is highly localized to particular countries like China, Korea, Japan. These are the main players of the battery pack production. Then reuse and recycling. Already recycling and reuse and some new dimension of research is coming, like second life of the battery. So in order to reuse the manufacturing, we need to refurbish the battery. It is said that electric vehicle has more than 80% of its usable capacity for the secondary application. So this is a big scope of research. So the reuse and recycling is becomes a very important part of the supply chain. So China is leading the battery recycling, accounts for about half the global capacity. So these are the industry involved for various materials. So in lithium, we can see that Australia, Chile, and USA has more than 50% market share. Then in nickel, China, Australia, Brazil have more than 50% market share. In cobalt, China already dominated by 70%. Then cathode materials, it is in Japan and China, more than 55%. And finally, the anode material, which is almost dominated by China. So these are the industries. So in the future outlook, as per the expert, the premium category vehicles are likely to adopt high energy density batteries because it needs long range of the vehicle. So they will prefer nickel based batteries. However, low range urban vehicles presumably adopt LPF, iron based batteries. So unlike them, mid-range vehicles are expected to use manganese rich batteries for low cost purpose. So however, some new technological new invention also going on, like sodium ion based batteries and solid state all solid state batteries. So these are the new technology that are yet to develop to compete with the lithium-ion batteries. So finally, I'm going to the conclusion. So in this work, basically we are giving a brief ideas of the whole battery supply chain, and also we included the commodity price appreciation because it is significantly influencing the cost of the battery as well as the electric vehicle. So EV battery supply chain is a collective attempt of several industry chains such as mining, processing up to recycling. So as we have already seen the statistics that China is still a global leader in almost all the supply chain category, and despite the massive growth of EV fleets in Europe and USA, but battery production in USA and Europe is not yet compared to the China. So thank you. So I would also like to acknowledge the NEMO project and Dr. Azzopardi and my colleagues. So thank you all.